Yes, class. Am I audible to you all? In the last class, we had started with series and parallel combination resistors we had seen. So in series combination, how do we get the equivalent resistance? We just simply add them, take the algebraic system. Means R1 plus R2 plus R3 plus R4 till Rn. Then in case of parallel combination, we had seen that resistors are reciprocally added. Means 1 by R equivalent is 1 by R1 plus 1 by R2 up till 1 by Rn. And now see, one resistor combination we had already seen. We have to see infinite series. If your resistors are connected infinitely, means infinite number of resistors are connected. So how can you calculate? Because obviously it's not possible to calculate the resistor of each of the series. Infinite series is a different case. You have to solve it with a different method whenever you have infinite series. So we'll start it with a question only. We'll do this with the help of a question only. Otherwise, all the steps that I use to solve this, I'll tell you here. So let's take a question. Let's take, this is one resistor, this is another resistor, and so on. It is connected to infinity. Then this is connected. So let's say this is 1 ohm resistor connected with 2 ohm resistor, 1 ohm resistor connected with 2 ohm, 1 ohm resistor connected with 2 ohm, and this series is keeping on repeating. 1 ohm connected with 2 ohm, then 1 ohm connected with 2 ohm. How many resistors are there? So infinite resistors are there. Infinite resistors are arranged in this way. But calculation of it is very difficult. Had you been given only this much part, then you would have solved using your series and parallel combination. But now you have infinite resistors. Whenever you see this infinity case, firstly identify the repeating term. Are you able to notice this 1 ohm and 2 ohm? Both of these are connected. 1 ohm and 2 ohm. There is a pattern if you are able to observe 1 ohm and 2 ohm. This series is getting repeated. So the first step, whenever you have infinite series or whenever you have infinite resistors connected together, then the first step is to identify all the repeating terms. Repeating terms basically means whatever are the infinite terms. Even if there is one more resistor, external resistor connected, and it is not getting repeated, then that won't be included in the repeating term. So you have to identify which terms means which resistors, or this is also valid in case of capacitors. So if you have various capacitors connected, so you have to identify which all capacitors are connected. So first identify the repeating term in this manner, the way we have identified 1 ohm and 2 ohm. Now see, let's assume the total, whatever is the equivalent resistance, no, whatever is the answer of this question, means equivalent resistance of the whole infinite series. Let us assume that it is capital R, means our answer is capital R. So step 2 becomes what? Step 2 becomes assume that R equivalent is capital R. It means we have the answer which we are searching for or for which we are solving. This is capital R. Now, just tell me one thing. I have reduced the whole circuit, mean the whole infinite circuit, into one capital R. Capital R is my R equivalent. Even if I add one more term to it, will there be any difference? It means like this is my circuit. This is the repeating term. This is 1 ohm. This is 2 ohm. This is the repeating term. If this is added, external resistance. External resistor means what? Equivalent resistance. This was what? This was my whole infinite series. 1 ohm, 2 ohm, 1 ohm, 2 ohm. That whole is R equivalent, which I have taken as capital R. Even if I add one more term to it, see, there won't be any difference. Reason, it's like you have infinity. infinite series are there, and I'm just adding one to it, one more circuit. So even if I add one more circuit, that will almost be equal to infinity. Even if I ask you infinity plus one, you will say infinity, it will almost be equal to infinity. So in this case also, if this is 1 ohm and 2 ohms, even if I add one more repeating term to it, there won't be any difference in my answer. Reason, because infinite terms are already there, and I'm just adding one more term to it. One more term means one more circuit to it. So my whole answer will still be equal to capital R. So what's the third step? Third step is to add one more repeating term. Step 3, this is add one more repeating term. Why are we adding the one more repeating term? Because R equivalent, this remains the same. This remains the same. Now, we cannot solve the infinite series circuit, but we can solve this circuit. This is known to us. If this point is A, this point is B, and I have to find out the equivalent resistance between A and B, I will be easily able to find it. Can you people tell me how are both of these connected? Let's say this is 1, 2, 3. Parallel. Yes, Fatima. They are connected in parallel. So if they are connected in parallel, means R1 and R2 are connected in parallel. So R1 and R2 both are connected in parallel. So R equivalent will be what? Not R equivalent. R12. R12 will be equal to 2 was there and R was there. So 2R divided by 2 plus R. Just I've taken the parallel combination of them. Now see how the circuit looks like now. 1 ohm is there. Both of them have been reduced to single term. This is A point, this is B point, this is 1 ohm. Now this is R12. This is 3, this is not R2 now. This is R12. Means 2R divided by 2 plus capital R. Yes, now tell me how both of these are connected. Series. So in series, I just directly have to add them. It means 2R plus divided by 2 plus R plus 1. So this is what? This is the equivalent resistance, and this is equal to still what? This is still equal to capital R only. Reason? Why is it equal to capital R? Because infinite terms were there. We have added just one more term. This has been added only, no, by ourselves. We have just added this one more term. Still, it won't change the equivalent resistance. It's like adding 1 to infinity. First, tell me, is this clear to all of you?
Yes, teacher.
So now you just have to perform mathematical calculations and solve R. Just take the LCM, it will be 2R plus 2 plus R divided by 2 plus R. This is equal to capital R. So 2R plus R, this becomes 3R plus 2. And just multiply capital R with 2 plus R. So 3R plus 2 is equal to, if you multiply and open the brackets, this becomes 2R and this becomes plus R square. Bring everything on the right hand side. So 0 will be equal to what? This will become R square. R minus 3R becomes minus R, and plus 2 when it comes into the right hand side, it becomes minus 2. So you have an equation with you now. If you remember splitting the middle term can easily find this answer. Otherwise, you must have done a whole quadratic equation, how to solve it. B plus minus under root D, where D is B square plus minus 4AC, that one. But this is an easy equation, so it can be directly solved. 0 will be equal to R square. This will be minus 2R, and plus R, it will be plus R. So 2 into, yes, it is giving us minus 2. And then minus 2, this is equal to 0. From here, R will be, okay, 0 I've already written. No? Now from here, if you take R common, this becomes R minus 2 left. From here, plus 1 is left. and here also minus r minus 2 is left. This is equal to 0. So one bracket you get as r plus 1, other bracket you are getting as r minus 2. Simply these are from your 10th standard calculations, splitting the middle term to find out the answer. You just have to solve the equation now. So this becomes minus 1 ohm and this becomes plus 2 ohm. So out of all both of these, which one should I choose? Minus 1 ohm or 2 ohm? 2 ohm, because resistance cannot be negative. So this one gets eliminated and our final answer is 2 ohm. So see, our capital R is 2 ohm. Capital R was what? The whole answer of this, means equivalent resistance of this infinite circuit. Clear? Start writing down wherever you get stuck, just ask me in between. This is how you solve infinite circuits. Even if capacitors are given to you, just identify the repeating term, equate it to capital R. In case of capacitor, take capital C, and any repeating term can be given. Here also you can get additional resistor. You just have to identify the term which is getting repeated. If you see a resistor over here which is not getting repeated, so leave it. Don't consider it in the repeating term. So series parallel combination of resistors we have practiced. Before moving on to the next topic like Kirchhoff's law or any other topic, I think we should practice some more resistors, some more circuits. So first note it down. I'll give you 2 to 3 circuits. So all of you try that, submit your answers, see whichever portion is your weak of resistors, because combinations of resistors become tough terms sometimes to identify it. Hanifa, just retry it. For the first one, just retry it. All of you have to find the equivalent resistance between A and B. A and B points I've mentioned. First, Atif, yes, correct. Atif, first one is right. Try the second and third part. Others also, please try. Akifa. Akifa, you were absent in the last class, no?
Yes, ma'am. I had unit tests.
All right. Yes, Sarah. Good. First answer is right, Sarah. Fatima, both the Fatima, Hamza, Hiba, Kulsum, you also people try. Third one, Atif. No. Please retry. Try it again, see. Second one, no, Sarah. Slight error is there. Check again for the second one. Hanifa, this is the answer of which part which you've said for the first one? Okay, Akifa, first one is right. See, let's discuss the first one so that people can try the second and the third part. See, if you look at these, both is third one, no. Sarah has also given answer for the second one. No, Sarah. Try again for the second and third part. Let's discuss the first part. For all those who are not able to, then try the second and third part. See, these are connected in which way? They are connected in series. Similarly, they are also connected in series. What about Fatima? Fatima, did you get any answer for the first part? Fatima?
I got some wrong answer. I got a point answer.
Answers in decimal. And what about you, Fatima Munir? Fatima? Any answers by you for the first part? Still trying? Okay. See, both of these are connected in series. So this becomes what? This becomes 10 plus 20. That is 30. So this is 30. Again, this is what? Both these are connected in series. So this becomes 60. Now you have 30 and 60 connected in parallel. So answer for the first part. R12 becomes 10 plus 20, that was 30 ohms. R34 became 20 plus 40, that was 60 ohms. Now R equivalent will be what? Parallel combination of both of these are connected in parallel. That becomes 30 into 60 by 30 plus 60. This is 1800 divided by 90, which is 20 ohms. This will be the answer for the first part, 20 ohms. So 20 ohms is right. Hanifa, did it get clear for the first part? Hanifa.
I actually didn't take the 16.
Okay. All right, the 60, no? Fine. Now you people try the second and third part. First part is still easier to solve. Second and third part. Whatever answer you're giving, just whatever answer you're getting, just submit it. Let me give you a hint for the third part. In the third part, this is a case that you already know. The method to solve third part, you people already know. It's just that you're not able to identify it for the third part. Second part also try. No, Sarah, not this answer for third part. Try again. All of you, only Atif and Sarah are trying the second and third part. What about others? Kulsum, answer for which part? Second part, correct. Kulsum has got the right answer for the second. Kulsum, try the third part as well. No, Atif, not 4 hour. See, for the third part. Third part answer, yes, Kulsum. Kulsum has got the right answers for both the parts. See, for the third part, it's a case that you should identify. It's just that the wires have been curved, means if it is given in circular form. Last 2 minutes, then we'll discuss it. Hamza's answer for the second part. Slight error, Hamza. Slight error is there. Fatima answer for the third part. No, Fatima. Shara, you're close to the answer of second part. Just check it once again. Yes, now it's right. You must have forgot to reciprocal it, no? Now it's correct. So Sara and Kulsum for the second part. See, yes, Kulsum. How did you solve the second part, Kulsum? Okay, not Kulsum. Sara, you tell us. How did you solve the second part?
I took all the resistors in parallel.
Parallel connection. See how you'll get the answer and how to check whether it's connected in parallel or it's connected in series. You are given points. First, check all the points. Whenever you see no A and B, it means there is a battery connected. The way had I given you only this much portion, then this battery that has I have shown to you, that you would have to assume yourself. Now see in the second part, if I pull it from A, if I just pull it from A, see how will it look like? How it will look like? This is all these are smaller connected. This is one point A point. If I pull it from A in this manner, in this way, if I pull it like this, see, it will look like this. This will be the point A. This will be 1R, second resistor, third resistor, and the fourth resistor. This is point A. So can you see all four are connected actually in parallel? If you pull it, just a way of calculation. So you see all four are connected in parallel. And whenever resistors are connected in parallel and they are identical, then directly divided by the number they are having. For example, if two resistors are there, capital R, and they are connected in parallel like this, then simply R equivalent will be equal to R by 2, number of resistors that are present. So here also R equivalent will be what? Small r divided by 4, number of resistors. So R by 4 is the answer of the second part. Now you people try the third part. Take a last minute to try the third part, see if you're getting any answer. Someone wants to note down, so you can. If you identify the method for the third part, then you will be easily able to solve it. We have done this case in capacitor. Another hint, we have done such case in capacitor. Yes, Atif. Now your answer is right. Sarah, still error is there in the answer. Only Sarah and Atif, both of these are trying. Kulsum has given the right answer. And what about others? Hanifa, Fatima, no. Just one method, identify the method. Try to recall which method is this. That will lead you towards the answer. Hamza, any answer by you? One I have seen. Hamza, Hiba, Fatima. Fatima, Munir, are you there? Okay, then you also try, Fatima. No, Akrama, no. See, who all have given the correct answers? Atif has given. Kulsum has given. Kulsum, how did you solve the third part? By which method? Kulsum? All are in parallel. No, Sarah. Hamza, you're getting R in the numerator and R in the denominator. R will get cancelled. All are connected in parallel. Then it will be R by 4. How did you get the answer? Kulsum, for the third part I'm asking. All are connected in series. Then it will be 4R or it will be 6R. You've got the correct answer, Kulsum. Just the method I wanted to ask. How did you do it?
He said he called me. I had gone for a while.
No. I
Okay.
was calling Kulsum. So yes, Kulsum, series, all are not connected in series. Which are connected in series, which are connected in parallel? Just let me know. That I'm asking to you. You can unmute yourself, Kulsum. Okay, Atif, you have also given the correct answer. Atif, can you tell us how did you solve the third part?
Yes, teacher. The circuit is in the form of a Wheatstone bridge. So the
Wheatstone Bridge, exactly. See, Wheatstone Bridge. Others, listen. Wheatstone Bridge, you people have already done. Okay, mic is not working. All right, Kulsum. Atif has answered. See, this is a case of Wheatstone Bridge. Kulsum, you also listen. You had done it in a different way. The answer was correct though, but it can come out wrong in other circuit. See, others. It's just that wires have curved. We have just curved the wires. The concept will still be the same. This is the case of a Wheatstone bridge. See, if I draw it in this way, in the form of a diamond or square, if I draw, then you people are able to identify that this is a Wheatstone bridge. Small r, small r, small r, small r is there. And this is having 2r. This is a Wheatstone bridge, so this is also a Wheatstone bridge. What's the difference? If I just curve these wires in the circular form, it will lead in the formation of this circle only. So curving the wire doesn't affect the equivalent resistance. This is a Wheatstone bridge case, and in Wheatstone bridge we have already studied. All of you listen this. Wheatstone bridge we have already studied that the middle one, there is no charge flowing through the capacitor that we had discussed. Similarly, there is no current flowing in this, in middle one, because the potential difference here, it is 0. So the current, there is no current flowing. It means you are not having this anymore. How will we have the circuit? For the third part, first remember that it's a Wheatstone bridge. Now, this circle is there, this resistor is there, then you have another resistor. Here wires are connected. Then you have another resistor, and here also wires are connected. You have to eliminate this middle wire because there is no current flowing. Now see, this is similar case to what we have done in the first question. These two are connected in series. So this becomes what? This becomes 2R, this becomes 2R. Then 2R and 2R, both of these are connected in parallel. So what did I tell you? Whenever you have equivalent resistors connected in parallel and they are identical, no need to perform all the calculations, just divide it by the number of resistors that are present. So 2R, both are identical, and the number of resistors that are present is 2. So what will be the answer? 2R divided by R, R divided by 2. 2 gets cancelled, R equivalent comes out to be equal to 2. Not 2 ohms, small r. Small r is the resistor. Now let me know wherever you people are having doubts. All right, small r will be the answer to it. Just note it down, note all the parts. Wherever you are having any issues, just let me know. Wherever you have to note it down, just note it down. Then we'll begin with the next topic, Kirchhoff's law. So half an hour more we'll study. Then you people can ask doubts also. So this completes with the resistors combination, series and parallel combination of resistors. Now, Kirchhoff's law is also a method to solve your circuits. So Kirchhoff laws, these consist of two laws. You have a full network with you, the whole loop is there, you have a junction with there, you have all the branches of the networks, and then in between them you calculate the current flowing and all the combination of resistors. So the first law that is there, this is known as the Kirchhoff's first law, which is known as the junction law. This is known as the junction law. This basically says that all in an electric circuit, if you have an electric circuit present, then whatever currents are coming and whatever currents are leaving the junction, at a particular junction, currents must be coming in and some currents must be leaving it. The net or the sum of all the currents at the junction, that is zero. It means, let me write down the law first. This says that the algebraic sum of currents at any junction is zero. So when can this be valid? If all the currents which are entering is equal to all the currents that are leaving, means your summation of all the currents is zero. This means what? Whatever current are entering. Like if I say this is a junction, this is one resistor, this is another resistor, this is one resistor, and this is another resistor. So this is the junction of all these resistors. See, if I say I1 is, the direction of I1 is this, and the direction of I2 in this branch, this is this, I2 is this. Direction of I3 is this, and direction of I4 is this. These are all the currents that are flowing. Now I have to calculate at this junction. This is the junction. That's why we call it as a junction rule. So what will happen? Always take the currents that are flowing towards the junction as positive. Towards the junction as positive. And whichever are away from the junction, then you have to take it as negative. So in this, yes, Hanifa, you tell me, out of all these currents which are moving towards this junction, this is the junction. Yes, Hanifa?
The first one.
The first one and one more. Just see which is moving towards the junction.
Second one.
Second, good. First and the second one. It means I have to take it as positive. So this becomes plus I1 plus I2. This is the way I have to take it. Fatima, Munir, you tell me which are moving away from the junction, which currents are moving away from the junction. This is your junction. What all currents are moving away from it? Fatima. Yes, Fatima. Okay, you answer, Fatima. Fatima Ansari.
I3 and
I3 and
I4
I4. Exactly. These are leaving this junction. If these are leaving this junction, it means we have to consider it as negative. So this becomes minus I3 minus I4. This is equal to 0. So I1 plus I2 is equal to I3 plus I4. This is the first law of Kirchhoff. Then you have one more law, the voltage law. So this is also known as KCL. This law is also known as KCL. KCL means Kirchhoff's current law. Kirchhoff's current law. So this is also written as KCL also sometimes. Now the second law that you have, Kirchhoff's second law, which is also known as the loop law. This will be used most of the time. We'll be practicing questions on this because current law is easy. See, you can easily identify using current law. First, we'll use current law and then we'll combine it with the second law. So both the laws of Kirchhoff will be used simultaneously to solve any circuit. And you know, whenever you get stuck in between the circuits, no, you're not able to identify whether it is series, whether it is parallel, or you're unable to solve it further, then Kirchhoff's law is the best method. You can use it for any circuit. There is no exception to it. That you will see how you can apply it. So basically this says that if a closed loop or network is there, I'll write down also. Around any closed loop of a network, algebraic sum of potential here becomes 0. Algebraic sum of all the potential here, it is 0. So algebraic sum of changes in potential is 0. So it means change in potential here, it becomes 0. This is known as KVL, Kirchhoff's voltage law also. So sometimes it is written, you will see some certain books, it is written either as according to KCL or using KVL. So whenever KVL is written, that means Kirchhoff's voltage law, which is this law only. Two laws are only there, which you have to study. So this is Kirchhoff's voltage law, KVL. So across any junction, this we'll see in detail. Now, applying the direction, whatever is the sign convention on loop, the way we had seen the sign convention, sign convention for this junction. So sign convention, if you are to take, remember, if you are moving from the negative terminal to the positive terminal, negative terminal towards the positive terminal, then this is taken as positive E, whatever is the value. For example, 12 volt is there, then you'll write plus 12. If this is the direction of current that is flowing, this we'll see with the help of current only. From positive to negative, then you will take it as minus E. This is which case? This is case if you are given batteries, because in a circuit you will be given cells, and what else you will be given? You will be given resistors as well. Now, if you have resistors, let's say this is a resistor. So, direction of current, let me say the direction of current is this. This is the direction of current. Now, remember, let's say the resistor is capital R. Current always flows from higher potential to lower potential. So this is what? This is from plus to minus. What did I say? It has to be from negative to positive for being positive. So if it is in this way, now this is what? This is from higher potential to lower potential. So this is also right. This is from higher potential to lower potential. So V can be written as, in this case, as plus IR. If we take the reverse direction, this is the direction, not this direction. Or let's take this direction only. This is the direction. that we are considering, but let's say this is negative and this is positive. This will be the same case. This is first one is positive, other one is negative. This case we are talking from negative towards the positive it is going. If it is going in this way from negative towards the positive, then you have to take it as negative. V is equal to minus I. See, this sign convention will solve all your questions. First sign convention is this. For solving any circuit. For solving any circuit that you have, use this first. Whatever junction you are considering, there will be a point in the circuit no, which will be positive or which will be negative. If you see any circuit or just select a junction, once you have selected a junction, you've seen a junction, you've selected a junction. Then after choosing or the selection of the junction, you have to check whether whatever currents are flowing towards the junction, whatever currents are flowing away from the junction. Now, if you see battery, firstly you will mark all the current direction of current. Now, how to write it? If you see this case, this case means what? Current is flowing from the negative towards the positive. Then directly write it as plus. Directly write it as plus. If you see it moving from, or this is case of cells. This is the case of cells. And then you have the case of resistors with you. This was the case of cells, and then you have the resistors with you. Here you have the resistors. Now, for example, if I give you an example like this is a resistor. This is, let's say, 4 ohm and some I2 current is flowing. With the help of example only it will get clear. Then you will be able to understand what has been written up here. Let's say this is moving. This is some I2 current and 4 ohm is there. Now, this voltage will be what? Voltage will be current multiplied by resistance. So voltage will be I multiplied by R. I is what? I2 and R is what? 4I2. Now, in the circuit equation, how will you write? This is positive, this is negative. What did I tell you? From positive to negative, it is moving. So, it is moving against the direction. So, you will be writing it as minus 4I2. This will be the direction. Now, if you reverse it, had it been moving in opposite manner, this would have been the direction, resistor sign would have been changed. Then you would have used plus 4I2. This will get clear when we'll be doing circuit. But this is just an example to show how to write this, how to go about it. How is the direction of current flowing. That we'll see in the circuits as well. First, note down all these points. When to see negative EMF, when to check for positive EMF, for resistors also. First, now note down the points, and through the help of the circuits only this will get clear. At least one circuit we'll discuss. Are you people attending those extra classes of JEE and NEET? Anyone from this batch who's attending those extra classes?
No, teacher, I'm not attending.
You people are not attending. All right. So if by any chance you people have to attend and the timings are from 8:30 p.m., 8:30 KSA timings, then will it be fine for you people? Or it would be late for you all? These classes happen twice a week. And Azam sir himself is taking those classes now. So if you will be needing to attend those classes, so is 8:30 KSA fine for you people or is it late for you? Whatever suits you, just write yes or no. If you think yes, 8:30 is fine, you can attend if you are required to attend those classes twice a week at 8:30. Then let's just write yes in the chat box. If you think that's too late for you all, then write it as no right now in the chat box. So I'll know who all are agreeing to this and who all disagree.
How
All the
long
classes, 1.5 hours, 1.5 hours. Only Hamza has responded, others also respond. See, most of the classes of your batches get over by 8 p.m. So you will have a gap of half an hour and then from half an hour you will be having your class from 8:30. Because those students who are attending those classes, I think Krishna was attending from this batch, he is absent today. So those timings are getting clashed with your other classes, your chemistry classes or sometimes physics classes. So that's why it's just asked or a suggestion is wanting from you people whether 8:30 p.m. is fine for you all or not. So only Hanifa and Hamza have answered. Others also just respond with a yes or no. This is not a class physics question. No, Fatima. Even if you're not attending, just respond because just in case if you are required to attend, so if that time suits you or not, just yes or no. Students who have responded are Kulsum, Fatima, Atif, Hanifa, and Hamza. Only these have responded. 5 students. Other Zakifa. Just write a yes or no. Sara, Hiba. Yes, Sara. It will be 11 p.m. for us. Then it will be 11, 12 to 12:30 for us. So as decided, are you people prepared for the test? Capacitance, I told you, no? In the last class, you all had agreed for Thursday. Yes, Atif, Sarah, you people were there if I remember. Fatima had left earlier. Okay, then we'll have a test of half an hour in the class. Only capacitance topic is fine, I think, by all of you who all were not there. Akifa, is it fine for you if capacitance test you have to give it right now? Because you were absent in the last class, so I think you must not be informed about the test.
It's fine.
It's fine, no? And Fatima, what about you? Fine?
It's okay.
All right. Okay, if anyone, I think Kulsum, you were also absent in the last class. Kulsum? Hamza was present. Okay, Kulsum, you were also absent. Anyone is having issues with just capacitance topic test? Half an hour test, I'll take it right now. So you can take 5 minutes more. So are you people done with the writing portion? Can we start with it? All right, then. Take out your spare sheets and you can take 35 minutes, mean 5 minutes more for uploading. Otherwise, and that duration of the test is of half an hour. If you are unable to see the figure, no, then just let me know. I'll redraw it.
Teacher, the figure is very small.
This figure, Fatima, or both the figures?
Both of them. Like I can't read the
See,
values.
the first figure is like this. This is A point, this is B point, this is C1, C, this is also C1, this is C2, this is again C1, this is also C1 and this is C2. So C1 is having value 3 picofarad and C2 is having value 2 picofarad. This is this is visible, no, Fatima? For
Yes, teacher.
question 1. Second, for question 2, I'll redraw the figure. Battery is there. Positive, negative terminals are there. There are 2 capacitors connected and 1 more capacitor here. So this is 3 microfarad, this is 6 microfarad, and this is 12 micro. Hanifa, you have submitted, no? Hanifa? All right, Hanifa, I've received yours. You can leave it. Now you people have your WhatsApp groups, no? You are added with me in the WhatsApp groups. You can send it there also. So last 10 minutes are left. Akifa, send it on the WhatsApp group. Are you added on the group, Akifa? Now WhatsApp group has been created, no? So there I am also added directly. So I'll receive it directly.
Okay.
Okay, submit. All of you. Boys have a separate group, girls have a separate group. I'm added in both the groups. So you people can submit your answers there only directly to me. Don't send it on the Learnivio number. Send it to me directly on the WhatsApp group. Okay, Akifa. Akifa, have received yours. You can leave, Akifa.
Thank you, ma'am.
Yes, Fatima. Fatima Ansari, I've received yours. Yes, yes. Fatima, you can also. Atif, Hamza, Hiba, Sara, quickly wrap up your answers, make it into a PDF and upload it on the WhatsApp. Last 3 to 4 minutes are left. Consideration part, as in consider a parallel plate capacitor having this values like this. You're short of time, Hamza. Now just write it quickly. Right now, you don't just leave it. Otherwise,
Ma'am, actually, I have like derived it, but I left some space now. So
okay,
left
okay.
space.
Then write it. Then write it. If you have
Okay.
it, then write it.
Okay, ma'am.
If you have written it, then it's fine.
Teacher should send in the group, right?
Yes, on the group only. WhatsApp group that has been created. So Atif and Sara I have received. Atif and Sara. Yes. Hamza and Hiba are left. So Atif, Sara, you can leave. Atif have received and Sara. All right. Hamza, Hiba, hurry up. Hiba, Hamza, hurry up. Your time is up. Extra 10 minutes are there. Quickly submit it, whatever you have done. Submit it now.